This video is going to go over complex numbers. In section 8.1, we learned about square roots such as the square root of negative 16 and the square root of negative 4. So the square root of negative 16 is saying what times itself will result in negative 16. Well, 4 doesn't work because 4 times 4 is 16, and negative 4 times negative 4 is also 16. So what we wrote was there was not a real number that would work. Since there is no real number, when you square it, that can equal a negative, we are going to call that not a real number. However, moving forward, we are going to be able to compute with numbers like this if we are using the complex number system. So how are you supposed to know to do what I'm showing you in this video? The directions have to say something about working in the complex number system or using the letter I to write your answers. So after you leave this class, you would have to ask a teacher, or the directions would tell you whether you're going to write not a real number or whether you're going to perform the actions I'm going to show you in this video. So complex numbers are used in many aspects of science, such as engineering. Centuries ago, mathematicians realized the square root of a negative number arose when solving certain types of equations. They actually referred to these types of equation as imaginary or ghostly. Mathematicians devised a new number system to include numbers like the square root of negative 16, the square root of negative 4. To make this video not super long, I will post separate videos explaining this for those of you who are intrigued about why we do what I'm about to show you in this video and why we use the imaginary number system. So I found some videos do a really good job at doing that, so feel free to watch those. Either now, you can pause this video and look for those on my website, or you can watch them after you're done taking these notes. Normally I do play them in class, so feel free to do that. So moving forward, to do any of these problems, so for example, the square root of negative 16, we would normally write not a real number because there is no number times itself that results in negative 16. However, moving forward, instead of writing not a real number, you'll know to do this because the directions will say in terms of I. So we can rewrite the square root of negative 16 as the square root of 16 times the square root of negative 1. So we're essentially taking the number and making it positive because 16 times negative 1 would get you the number in the inside. So we're going to rewrite it using the square root of negative 1. And then, to represent that this was not a real number and to use the complex number system, whenever we have the square root of negative 1, we're going to replace it and substitute it with the letter I. So again, if you watch those videos, it will explain more why we do this. So we're going to substitute. Instead, we are going to remove this and put an I there. So the square root of 16, now we're able to do that, and we would get 4 times I. So we can write 4 times I as just 4I. So the number I is the number whose square is negative 1. Okay, so anytime we have the square root of negative 1, we're going to replace it with the letter I. Now, this is not a J. This is my attempt to writing it. It's an italicized I. So again, this is not the letter J. This is me trying to write an italicized I. So italicized I has this little curve right here. So then, if we were to, this is the one computation we need to do all the rest of these problems. So with that being said, if we use what we know about exponents, so if we square both sides, we would get that the radical goes away, and we're left with negative 1 equals I to the second power. So that's where this other substitution comes from. So these two substitutions are what we're going to use for this entire 8.7 lesson. So you can get this one from just knowing this. So this is what you do need to know. This is the one thing you have to memorize and understand to be able to do all these problems. Because then if you just square both sides, that's how you get the other substitution that we need to do these problems. The other thing that's new for us when we're working in the complex number system is how to leave our final answer. So normally, when you write your answer with variable expressions, if you had 2x plus 3, we always write the one without the variable last. So for example, if we had 2x squared plus 5x plus 4, this one's always last, the one without the variable. It's the opposite when you're working with the letter I, the imaginary number system. Instead, the standard form is to always put the imaginary part after the real numbers. So think of the I like a variable, and usually we're used to it being in the front, but here they put it in the front. And you can't add these. You can't add 3 plus 5i because they're not like terms. So again, we always, in the complex number system, we put the constant number in the front. Okay, so let's practice this here. This says, what times itself is -7? This is not a real number, but because the directions tell us to use this substitution of I, we're going to split it up as the square root of 7 times the square root of -1. And then we know, we have this memorized, whenever we see a square root of -1, we replace it with I. So we'd have the square root of 7 times I. So we can write our answer like this. Now, I will write the I in the front of the radical, because this still means multiply when you have two things next to each other. But I'm going to write the I in the front, because I don't want anyone to think that this I is in the radical. So that's why a lot of people, you'll see, they'll put the I in the front, which is really weird, because I looks like a variable, and we don't ever write our answer like x2, we write it as 2x. So again, I'm going to write the I in the front so it doesn't get mistaken for being inside the radical. All right, next one, we have the square root of -8. So I'm going to split that up into the square root of 8 times the square root of -1. So then this will be replaced with I. Now I can simplify this one just like we learned in section 8.3. So to simplify the square root of 8, I have to think about whether there is a perfect square that goes into 8. Or you can make a factor tree. So for example, I know I can write this as the square root of 4 times the square root of 2, because 4 times 2 is 8. And then the square root of 4 is 2. What times itself is 4? 2. And then we can't go any further with this. So we'd have 2 square root of 2 times I. So again, you can write your answer like this. Because this is just multiplication, this is three things here being multiplied. The order of this doesn't matter. So you can write it like this, 2 square root of 2i, but then it could get mistaken for being inside the radical. So I'm going to move it in the front because I can move the order. I'm going to write it as 2i square root of 2. So again, this is the exact same thing. Multiplication allows us to write it in any order. Just like if I have 3 times 4 times 2, I could do 3 times 2 times 4. When I'm multiplying, the order doesn't matter. I'm still going to get 24 for both of these. So same thing here. So that's why I'm just going to move the I right in the front so it doesn't look like it's inside the radical. So this is my favorite way of writing it. All right, let's go ahead and take a look at example 4. So the square root of -25, what times itself is -25? It's not a real number, but because we're working in the complex number system, we are allowed to write it like this. And then the square root of 25 is 5, and then this we're going to simplify to I. So then we have 4 plus 5i, and we can't combine this because they're not like terms. So we're going to treat this complex I just like an x. And just like we can't do 4 plus 5x, we wouldn't be able to combine these. So remember, in standard form, the real number goes first, so this goes first. So if you write your answer like this, It's not wrong, it's just not in standard form. So standard form, you put the constant first, the complex part second. Okay, so if we take a look at the next one here, so we're going to have 4 plus, and so if I ignore this negative, what times itself is 36 is 6, but because it has a negative, we would write it as 4 plus 6i. So again, we would change it to 36 times the square root of negative 1, and we would replace the square root of negative 1 with the I, and the square root of 36 with 6. And then we can't add these together because they're not like terms. One has an I, one does not. All over 2. Now in chapter 7, in section 7.3, we learned that when more than one thing is being added and it's just divided by one term, that we are allowed to split it apart and write it as 4 over 2 plus 6i over 2. So then 4 divided by 2 is 2, and then 6 divided by 2 is 3. So we can write our answer just like that. Now, depending on if your online homework wants it separated like this, you could also get your answer by keeping it all together as one entire fraction and asking yourself what divides all 3 of these numbers. So since 2 goes into all 3, you can keep it all together without having to separate it. And then 2 divided by 2 is 1, 4 divided by 2 is 2, 6 divided by 2 is 3, and then you'd have 2 plus 3i that way as well, because when you divide by 1, it doesn't affect anything. Okay, let's try one more here. So again, we could split this up into square root of 12 times the square root of negative 1 instead. And then the square root of negative 1, we can replace it with I. And then the square root of 12, we would simplify just like we learned again in section 8.3. So the square root of 12 can be written as square root of 4 times square root of 3, and the square root of 4 is 2. So now we can rewrite this as 3 plus 2 radical 3, and then we have the I all over 4. Now again, I don't write it like this because it looks like the I can be in the radical. So instead, I recommend writing the I in front here. So it's 2I radical 3. Okay, so now if you decide to write this all as one fraction, you ask yourself, can anything divide all 3 of these numbers? All 3, not just these 2, all 3. And if the answer is no, you could leave your answer like this. Now I believe on your homework it wants it in standard form like this as 2 separate terms. So if it doesn't accept this as an answer, then you would separate it and do 3 over 4 plus 2i rad 3 over 4. So separated as 2 terms. Because then you have the a plus bi form where you have the real number separated from it. Then you can't simplify 3/4, but 2/4 here you can. So you never want to include the radical part when you're dividing and simplifying, because this is not 3, it's the square root of 3, which is some decimal. So we're going to go ahead and divide by 2 here to simplify our monomials here. And we would get 2 divided by 2 is just 1i. And then 4 divided by 2 is 2. So you can write your answer if we separate it like this. Some people may also write it like this, where they'll put the I after. Again, I don't do that because I don't want it to look like it's part of the radical.